Okay, so here is the second video trying to explain this concept of limits from a numerical point of view. I've already entered the new function in the calculator. You can see it there. It's x squared plus x minus 6 divided by x minus 2. And remember, this is a rational function. In other words, it involves a fraction. So you have to put both the top and the bottom of the fraction inside their own parentheses. Anyway, everything is set up to go. Just to make sure that we know what we're doing, we go to second and table setup. And you can look here at the important thing. The only important thing on this screen is that we have set the independent variable to ask. So if we now go to the table and create the table, so second and graph will bring us to the table screen. And what we're going to do, we're going to put in exactly the same numbers as we did in the previous example. So we'll start close to 2. We want to take the limit of this function as x approaches 2. So start close to 2 with 1.9. That's what we did the last time. We see the value of the function is 4.9. So when x is 1.9, f of x is 4.9. Now we get closer and closer to 2 with our x values. So x 1.99, y1 is 4.99. Let's make x 1.999 and f of x is 4.999. And you can see that just as we did before, as the x values here, 1.9, 1.99, 1.999 get closer and closer to 2, the y values, or the f of x values, 4.9, 4.99, 4.999 are getting closer and closer to 5. Again, just to make sure that 5 is our limit, we have to check numbers on the other side of 2 as well. We have to check x values on the other side of 2. So let's start off with 2.1. When x is 2.1, y1, f of x, is 5.1. y1, remember, is the value of the function. So we want to work back closer to 2. So we had x equals 2.1. Let's make it 2.01. And let's get even closer to 2.001. And we could keep going back closer and closer and closer. And up until the point where we actually reach 2, we're going to find out that the y values, the corresponding y values, get closer and closer to 5. So looking at that screen, you could say quite confidently that the limit of f of x as x approaches 2 is equal to 5. And again, we haven't actually looked at what happens at x equals 2. Now let's do that. Okay? Let's just put in x equals 2. We have agreed that the limit of f of x as x approaches 2 is 5, because as we get closer and closer to an x value of 2 from either side, the y value is getting closer and closer to 5. That is all you need to say that the limit of f of x approaches 2 is 5. That's not going to change. The limit of this function as x approaches 2 is 5. But let's see what happens when x actually is 2. When x is 2, this function returns an error. In other words, it is not defined. So this function does not have a value when x is equal to 2. The previous example had a more simple function. It was x plus 3. And when x was equal to 2, that did give you a value of 5. But in this case, this function is not defined when x equals 2. So the question you have to ask yourself is, does this change the limit? And it doesn't. The limit is still 5. The limit of this function as x approaches 2 remains 5. What happens at 2 is not important in terms of limit. The limit is only determined by the number that y1, or y in this case, appears to be approaching. It doesn't actually have to reach the number. It doesn't actually have to get to 5. In this case, the value of this function is never 5. But it gets closer and closer to 5 as x approaches 2. So it's sort of an unusual case. It's not something you see every day, but the important thing to remember is the limit of the function is still 5, even though the value of the function is not 5. Okay, it's a little bit confusing. We'll reinforce this when we take a look at a graph of the function, and you'll again see a little bit more clearly why this is such. Okay, we'll go through this again in class.